now we are going to solve this problem. Given a string contains just the characters opening 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 bracket, uh, opening curly bracket, opening square bracket, closing curly bracket, closing square bracket, and closing bracket. The input string is valid if the opening brackets must be closed by the same type of brackets. Okay, so basically just the simple bracket problem. We need to figure out if the given string is valid according to the opening and closing of the strings, right? Closing of the brackets. So the first thing that we need to do, we need to create the mapping between opening and closing of the brackets. So first thing that we need to do, what should be the name of the variable? The name should be, I guess, the mapping. Mapping seems accurate. So for closing bracket, the opening will be like this. For closing curly bracket, the opening will be open curly bracket. Closing square bracket, um, the value will be opening square bracket, right? And then we need to go through the string. So the way we do it, we will basically go through the elements of the string. So for C and else, right? We will check if C is in mapping dot values, right? Then we will just insert that. So we will create the current set, and we will be adding the brackets as we go through them within that current set bracket set, right? And so let me just not BS. Let's name that current for now, and we will add that to current set. So else if cn mapping dot keys, right? and current is not empty, right? Then what are we gonna do? We're gonna remove the element from the current, right? It should be set. It should be less. It will allow us to easily remove the elements from the back end of the list, right? So last element, right? The way we will do it, current dot pop, and then we're gonna compare it with the last element that is supposed to be the opening bracket. It is not equal to um, mapping. So if so, let's see. this is the closing bracket, right? If the last element that was added to the grant was not this, then we know that this bracket is not valid, right? This grant set is not valid. So we'll immediately return false. Um, okay, else we will just continue, right? And else we will add grant head to the C. So if length of grant is not equal to 0, then we know it is valid. Anyway, it is false, right? So let's see. Okay, so we are using less instead of set, so that's why we need to use append right there. Okay, so let's now submit the code and see. Again here we are not using set. That's in while since I use Python, so I'm making these mistakes. Okay, so next create element. So this is the next problem that we have. So next greater element of some element x in the array is first greater element, that is the right of the x in the same array. So yeah, first thing that we need to do for the first array, we need to find out the indexes of each element in num2, and based on that index we will scan the rest of the array to find the next greater element. Okay, so I guess that is the necessity. I was looking for a better way to do it, but I guess that's the only solution for now. I'll see later on if we can find a better solution. Right, so let's see. One indexes, right? So that we has it, and we're gonna go through num in frames. Okay, so actually we need to find and store the indexes of the elements in num2, right? And for num1 in nums1, right? First thing that we need to do, first we need to find the index in num2, right? The way we will find it, nums2 indexes, since we know that the values can root just in the num2, so we can safely use this code to find the index of the current element of num1 in nums1 in num2. Okay, so next what we're gonna do, so now we need to next greater element, and next greater element here, if this is not found, it will be -1, right? So num2 for num2 in nums2 starting from index in num2
It's 4 o'clock.
plus 1. If num2 is greater than num1, okay, so we have a result as a returning list. So result will hold the values that we need to return. So since num2 here, that is in the rest of the array, is greater than num1, and then we will append that to the result, and then we will break, so that we don't have to go through the rest of the array. And at the end we're gonna return result. Let's see if this is good. Oh, I see. So either way we need to append the value to the result, right? So that should fix it. Okay, so let's submit that. Okay, so that is fixed. That was actually the long problem. So implement stack using queues. Okay, so implement last in first out stack using queues. The implementer stack should support all the functions of the normal queue, normal stack, push top of empty. Implement my stack class, push method push the element X to the top of the stack. Top removes the element on the top of the stack and returns it. Top returns the element on the top of the stack, and empty returns to if the stack is empty. Okay. Okay. So now we need to create the two queues first. Q1 and Q2. That'll be like basically temporary, right? Okay. So to push the elements to the stack, Okay. So the thing that we need to do, we need to push the element to the stack, right? So to push the elements to the stack, we will just put the element on the back of the stack, back of the queue, right? But in the queue, in case of queue, we can just uh, take the element out from the front only, and adding the element will also be added to the front. No, yeah. So self.queue, adding the element is uh, same as stack in queues, so we don't need to do anything extra. There'll be push, there'll be append, next. So the bomb will be different. How it will be different? Because in case of cubes, the pop removes the element from the start of the cube. In case of stack, it removes from the end of the cube. Okay, so what we need to do, um, we need to first remove all the elements and put that in the temporary queue, and we will just not add the last element of the stack, right? So while self.queue q1, right? We will self.temp.append q1 dot pop left, right? Greater than 1, then we do that. Else, what we need to do, we just return self.q1. No, we don't do that yet. Mm, Stop. Okay. The same way as Bob, what we're gonna do,
Hello.
Hey, how did it go for you?
Yeah, well, was focused all through. How about
Hmm.
you?
Okay, working on the third problem I could solve too. So it was a good session. Thank you so much.
Alright, amazing. Thank you.
Thank you.